Okay, thank you.
Okay, please.
Yeah, so this is all about me, and I will now give you a glimpse of what I'm going to present today. Today, I'm a co-author in one of the paper, and I decided to present it here. So this paper is about design patterns and detecting design pattern through machine learning models. So I will start the presentation. Okay, Professor?
Yes, please. You have right to share screen. Your
Yeah,
screen.
thank you. Thank you. So you can see my screen, right?
Yes, yes. Not full screen, but we can see your screen.
Mhm.
Okay, nice.
Yeah.
Perfectly.
Okay, so the paper name is still in construction because we are not sure how to name it, but for now it is design patterns detection. And I have a co-author, his name is Ginizwa, and the second author is me. And the Ginizwa is kind of the expert in machine learning models, so he is the first author of this paper, and I am mostly towards design patterns and how the detection and which metrics should be used to detect. Okay, so to start, I will try to give you an understanding of what is design patterns. In software engineering, it's a very uh, popular thing. Everybody talks about design pattern, and so it's basically how your code is written, the code structure, but every code structure has some particular pattern. And what pattern, if we go back to the origin in 1994, there were these four people, gang of four, who kind of decided to solve a common software engineering problem. They kind of identify that in all the systems, there are some problem which comes some security problem, some communication problem, and they try to identify this common problem and try to propose some common solution for it, so that next time we are developing a system, we just know that in such system, such kind of problem can come, and we have a certain solution. So what these people actually, these are the four people, if you go, there are names of them, but they become very popular, and they basically wrote one book which is called Design Pattern Element of Reusable Object Oriented Software. So in this book, they actually describe 23 different design patterns, and from there onwards, all the software engineers and the programmers started using it very extensively. A lot of paper and books after that came, which was focused on architectural side, like how to put design pattern while you are creating the architecture of your system, and not when you write the code. And a lot of authors also kind of criticized these design patterns and proposed that, okay, this design pattern is not correct, or this is not deep enough, and so on. But right now, if we see, so this, according to this particular book, there are three broader categories of design patterns, which lies in creational, structural, and behavioral. So if I say creational, it mostly talks about in object-oriented programming how to create object, how to create classes, subclasses, and stuff like this. Structural is kind of how connection between different objects and classes. And behavioral is mostly about the dynamic thing, that how they talk to each other, instances and stuff like this. So these are like 23 if you count, and each one has, the behavioral has the most number of patterns which was recognized. But from here, it's the basic one, and most of the time we talk about it, but then there are a lot of variation which people use. And at present, if we see that a lot of frameworks has automatically, they have a lot of design patterns, so we don't need to, as a developer, think about, oh, which design pattern to use. We just use some kind of framework, and they already have established design patterns. Or also we can say that developers according to their experience level, use different kind of patterns. Some people has more experience, so they know which specific pattern they can use, and they sometimes also alter it and tailor it according to their requirement. And the developers who don't have much experience mostly use some kind of code structure and small design patterns in their code. But mostly we kind of rely on these frameworks which we are using. And a lot of design pattern we just use because we don't give it a thought, or we don't sit for hours and think, oh, which design pattern. We just use it because it's so standard and so common. So for now, the biggest problem is that there are a lot of design pattern, and if me as a developer, I take some open source code, or I start working on some new software system, I need to understand how the code is structured, how it is written. Simply, that's why if two developers know the same framework, they can communicate better. But if suppose I'm not aware, I have to go and look into the code and understand which patterns are being used. Or sometimes there is software documentation, we can use this documentation to better understand the product. Also, when we are writing, we also need to give it a thought that which pattern do I want to use? Is it even necessary, or how it is going to affect our software? Because we also need to think in terms of software quality. So which quality are important to my project, and whether or not these pattern which we are using is going to affect these quality attributes, let's say scalability or performance or modifiability in a positive way or negative way. So we should not separate using design pattern from the software quality. We always have to relate which qualities are important for us, and whether or not these patterns affect these qualities positively. They must affect them in a positive way. So it's important to understand the patterns being used in software products. Okay, with this, I would like to kind of sum up that our paper is about detecting these patterns in projects. So we take a project, we run our tool through it, a machine learning model, and this machine learning model will tell us what are the design patterns that are being used in this particular project. And then later, which we are yet to do, we need to find out the correlation and the quality attributes this particular project wants to aim. So what is the correlation and how is the effect? So we also try to do a literature review and try to understand that uh, who has done what. And because machine learning models are right now in hype and everybody is using for everything, so there were a lot of work which was done in this field. So a lot of authors try to use machine learning and try to detect design patterns in several projects. So so if we see here, this particular author, uh, in this particular paper, they tried to detect 5 different patterns. So they didn't consider all the ZOF patterns. So they took some of them, like singleton, adapter, composite, decorator, and factory method. So they just targeted these 5 and took some projects, and most of these projects were like, sorry, most of the projects were like not open source but a personal project. So they took some personal project and tried to detect this pattern and gave some result. In this particular, they use this tool, it's called Marple. It's a very popular tool, mostly used for Java projects. So you can this tool basically find clues of design patterns in your code structure. So goes through the code structure and try to see, okay, this clue may say that here maybe factory method is being used. And this is a very popular tool, and we can simply use it in our Eclipse. We can install the library, and then this we can run it on our project, and it will tell what kind of patterns we used. So they also used the same thing, and there was nothing new which has been done. And most importantly, it was only done on five design patterns. So okay, so Another limitation of this paper is very good, that's why I'm trying to mention a lot of facts about it. The training set they are using, they are just manual design. It's basically that I'm writing the code and just they took this code and analyzed. So they didn't use any large scale open source projects or any source code which is actually in use. So it were their personal project which they used. And so this was the major limitation. So we try to find another paper and try to see what kind of data set other machine learning models are using. So another paper we found again, they actually try to use open source project, and they use 9 open source repositories and try to detect design pattern on these particular repositories. But again, they had this limitation of 6 design patterns. So on this 9 open source repository, they detected these 6 design patterns. Here, if you also see, there are like accuracy measures. So it says like F1 score, which is 0.7 to 0.9, which is quite good. So the best F1 score is like 1, and the least is 0. So it's the score which says that how accurate our model is. So this was another paper which we liked very much. And then several other papers we found where they try to kind of have not diversion but more dimension, and they considered small scale and large scale source codes. So try to have this kind of dynamics, and they also measured F1 score from 0.6 to 0.67 to 696. So it was also pretty good. But then again, there was a restriction on design number of design patterns they are detecting. Mostly there are 5 to 6 design pattern which they are targeting, and then the data set they are using. So most of the time they take some source code 9 to 10, or they use their personal project. In another one of the paper, they strictly used only 3 open source benchmark projects, these the listed ones here, and they performed the analysis on only these 3 projects, and so on. So some of the paper also kind of try to find correlation between scalability and performance, and try to detect few uh, well-known patterns which can affect the scalability and the performance of software. Okay, so we have kind of found that there is some research gap. The major research gap which we kind of understood is that uh, they have machine learning models which are giving good scores, and it's good, but the problem is that the data set they are using are very limited. So we cannot generalize it that it is going to work for everything, or it will have the same accuracy for new projects. So the idea here is that we need to expand our horizon and take a lot of data uh, to train our model. So they have a variation. So one way, one of the paper did that, like small scale and large scale project, which is one of the way. Another way is to use a lot of open source project, because if we see open source projects, so many people edit it. So there is no one, standard which they are following. Everybody edit it in their own way or in their own experience. So a lot of variation can be seen in this open source project. So it's good to consider a lot of open source projects, so that we have a lot of variation which will help our machine learning model to get trained for better. So we decided that this will be the focus for our study. We will try to bring a lot of data set which can be standardized. So we will standardize the data set. So later other researcher can also use it for training purposes. So in this paper, mainly we focus that we will create this benchmark data set, and then we'll try to train machine learning models on this data set. And then we will see that the metrics it is giving, how it is different from which the previous papers which we use in literature review, how the score differ. Is there any difference or not? Or does this expansion of data set even make any sense or not? So this was like our main research focus. So first we decided to have a kind of pipeline. It's a standard pipeline, I would say. Nothing much new here. It's the same. You first extract the data, then uh, do some pre-processing on the data, and then you divide it into your training set and the test set. Then you train your model on the test data, and then training data, and then you test it on the test data to see what was the result. And then towards the end you generate some performance metrics, and in our case we will next compare it with already existing scores. So this is what our pipeline look like: extract, preprocess, then divide it into training and test, train it, and then test it. Okay, so for data extraction, firstly, we try to go to GitHub and GitLab and try to collect as many open source project we can collect. So it was completely based upon our understanding that which project we want to consider. And then later there was my co-author. He approached a course. It was a course on design patterns in Innopolis University, where students were taught about design patterns, and they had an assignment where they were um, supposed to create supposed to kind of find and also write codes with at least few design patterns whatever they are learning. And it was a kind of graded course, so student put a lot of effort in completing that assignment. And then of course everything was evaluated by the main instructor, so there was a kind of less chance that the projects are not good enough. So all these projects they created, they had some kind of design pattern. So we also considered this assignment from the students, and we used all these projects as part of our data set. So kind of consider a bigger data set. Okay, so actually, exactly 238, I guess, projects are there. I might be missing some numbers, but this is the exact or approx number of projects which we used in our data set. Okay, next is pre-processing. Mostly, it's we use CK metrics. So the idea here was to understand that how these projects are using the inheritance, the classes, how many subclasses, how many dependency, cohesion, and coupling, how they are in this particular metric. So in all these projects, we kind of took it and kind of extracted the CK metrics and decided that we will analyze it from here. Okay. Yeah, so in CK matrix, we basically have these 6 to 7 attributes, which is like methods in the class, inheritance, cohesion, coupling, and so on. To extract this, we also used again one open source tool, which is available on GitHub. Anybody can go and just use this tool for extraction. Okay, and now these are the machine learning models which we used to train, to test and train, and then compare the scores. We use sklearn Python library, and we just use the default training parameters. So we didn't change anything, we just use it as it is. Okay, so this is all about this. Now performance metrics, there were like 5 attributes: precision, recall, F1 score, and accuracy. So these 5 performance metrics were used. So I want to show the result, what we got till now. So all these data set we generated, as I said from the beginning, we mostly focused on GOF. If we go and learn about design pattern, there are numerous design patterns which exist, and a lot of them are basically the variation of this GOF. So the original design pattern written in 1994. So they mostly have the variation of it, but we just decided that we will just focus on these 3 major categories, which is creational, structural, and behavioral. And if I recall you again that in the literature review we did, they mostly do not concentrate on the broader category like creational, structural, or behavior, but they go inside this. Um, I want to just show you quickly. So here in most of the paper, they just take one out of maybe creational pattern, then one out of structural, and few out of behavioral. Or most of the time they take which is the most used, like singleton maybe, and the adapter, and then from here maybe observer or iterator or something. So they just do not focus on this broader category, but they just pick the most popular one. But what we decided that we are going to focus in general, so we are not going into deep, but we will say creational patterns that are being used, structural patterns that are being used, and behavioral pattern. So it will be more easier for us then later to correlate it with the software quality, which we expect that we will do it at some point. Okay. Yes, so that's why if you see our classification of our test and training data, they are basically classified according to creational, structural, and behavioral. Okay, so here is the exact number, and I think it sums up to something 253 training sets and 37 of test set for creational. And these projects, they are not completely different. So like when we are saying that creational 253, structural 55, behavioral 70, it means some of the projects, they are overlapping and have multiple categories of patterns. So this is the percentage. If we see the highest percentage of data we have is related to creational, and the least is about structural. So just looking at this pattern, we can say that there might be a bias in recognizing maybe creational design patterns, because we have huge number of projects which are using creational design patterns. So we are yet to think like how to interpret this data, and um, how to correlate it with the result, and how to find the limitation, and not find, we of course know about the limitation, but how to quantify, like how to put our limitations in numbers and say something about it. We are still in the process of writing it and understanding it. So from here, but we can see that there will be a bias in recognizing creational design pattern. So we should maybe add more on structural and behavioral part, but we have to see how can we add it. Okay, so now these three things, what you are looking at on the screen is basically these three design patterns: creational, structural, and behavioral. And these are separate table for each one of them. We kind of analyze the performance metrics for each machine learning model. So this is what the data looks like. The interpretation, we are still working on the classification, and we are still trying to find new data sets related to structural and behavioral, so that we can kind of conclude something good. So we still yet to analyze this, but for now, this is our result. This is how our result look like. If we see F1 score, the best F1 score is 1. It means our model, which we trained on whatever the data set, is perfect, and then 0 is least. So if you see for a lot of models is 0.6, 0.6. So average, if we see for structural case, it's 0.6, for creational 0.65, even the highest score is 0.72. And for the behavioral part, if we see, we have 5, I guess 6 is the maximum. So this is what we are getting right now. Okay. And here we try to again analyze our score with the previous scores. Like here, the data set 1, 2, 3, actually it's not the correct way to represent because it's still not done. But here we attempt to compare that what scores we are getting with other researchers who in past used some kind of specific data set, like they just used 3 major benchmark projects, and how our score is different than those benchmark projects. And then another data set which we are targeting is one with a small scale and large scale project, to see that how the score is varying, because in our case most of the projects are, I guess, medium scale, so not large scale or very small scale, but medium scale projects. So and this is the understanding of metrics if you really want to understand what is precision, what is recall, what is model accuracy. But these are kind of standard performance metrics which is being used in machine learning model. So anybody who's interested in giving us input in this sphere is always welcome. Maybe they can help us to understand that how can we establish the correlation metrics. But because from here onwards, we next need to map these scores to the software quality, which is like performance, scalability, modifiability, and so on. So this is our next task, and we are open to get inputs from researchers who are interested in this. So I said my presentation is not big, so this is all I wanted to present. And in future, maybe once we complete this paper, I would like to give you a full understanding of what we did, or you can continue from here.
Thank you very much. So time for questions. Since we have a lot of time, we can ask even long questions, and but please postpone comments a little bit. Let's make your comments a little bit later. Now, please ask questions. Any questions, please? Sergey, please.
Sorry. I like this direction because I was a teacher for design patterns for years. Yes, it's fun, and maybe some remarks on your presentation, because the main trouble that I got from this presentation is that you didn't show us how do you move from code to models that will be an input for some kind of neural network or different method. But you have a repository of real code. So could you please explain how do you move from code to some vectors or what?
Okay, so again, I'm not the machine learning expert, but I will explain. So basically, we take the code, so we have the data set, and then we kind of create this CK metrics. So
okay, so your input for like classifier or something like this, there are some sets of inputs, some sets of pre-calculated metrics, and you think that the metric actually represents a pattern. And have you checked the literature about it? This just your idea or another researcher's idea?
No, I think it's an existing idea, like this very popular tool, Marple. They also kind of find clues, and if clues are like different, it's code structure. So code structure, we can say it is also in terms of inheritance, subclasses, and so on. So they already use this standard to find the correlation. So we can correlate between the code structure and the pattern being used. So it's not our original idea, but it's already established idea.
Okay. So I think better research should be to analyze like code ASTs and find relations between code parts and not just calculating metrics, but make some deep analysis of code structure of class relations or something like this. I think it could show better result, but maybe I'm wrong.
No, actually, you are right. I know somebody at Innopolis who is actually working on source code embeddings, and they are actually trying to, but it's like a big topic in itself to understand it from the source code and trying to. So you are correct. Actually, it will be a deeper analysis, but for our paper, we just decided to use this metrics and not go that deep. But of course, it's a better approach, but it will be, I think, more elaborated, and it will be a bigger section if we go like that. So you are correct. I mean,
okay,
we can use here.
Maybe. And another remark could be that your data sets, and you said that your idea is create a good data set. And I know there are some conferences where researchers present their data sets, and yes, it's a good direction. But for my point of view, a good data set of full of patterns usage could be the source code of Eclipse itself, because if you look through the code of Eclipse, there are a lot of classes, and actually they use a lot of patterns, because Eclipse was created by the same people who wrote this book, like Eric Gamma was one of the initial author of Eclipse. So Eclipse, the tool, they use a lot of patterns. And when I was young, I wasn't able to understand this code because I had not known design patterns. And then I read this book on design patterns, and all became good to me to understand this code, because yes, they use a lot of patterns, and the code is written using design patterns. So like such systems, they use plugins. Maybe it's a good point to analyze and reveal some patterns. And I had okay.
Just want to clarify. So you are suggesting to include Eclipse in the data set, right?
Yes, source code of Eclipse. For example, you can get Eclipse RCP sources, and there are a lot of Java classes. Yes, but they also use a lot of XMLs, because they have some configurations, and XMLs are not nice, of course, because yes, they have for SGI system to start a plugin, and it's well documented, and it's fully open source. Okay. And I had some different opinions, but maybe different people say something, and I will think.
Yes, thank you, Sergey. Let's wait. Maybe some other people would like to ask some questions. Any questions from other audience? Well, I see. Vitaly, please, your turn.
Well, could you please clarify what are the implications of being able to detect design patterns automatically? What kind of problem we'll be able to solve?
So first thing is that in open source project, it will be kind of a documentation that what kind of patterns are being used in this open source project. So anybody who want to work on it would be able to understand it better. So this is one of the focus. But in organizations also, we generally do not document something about design pattern. We have requirement document, we have architecture, and so on. but lesser is about the patterns being used. One of the reasons is also that you mostly use it as part of some framework, and you don't give much attention to what kind of patterns are being used. So it could be used that documented in organizations and for open source project. But the next level is that, so we need to understand that is using such design patterns kind of how it affects the code quality. So like not code quality, like software quality. So every project has some software requirements. They do not focus on all the software quality, but some particular quality, let's say performance and scalability. Then we should establish some kind of correlation, because a lot of researchers already found this, that there is a correlation, of course. And we don't use pattern just for maintainability of the code, but the patterns we use directly affect this code quality, software quality. So we would try to establish from this automatic detection, we will try to find some kind of correlation that which pattern affects which software quality and in what way. Does it make sense?
Vitaly?
Yes, makes perfect sense. Thank you.
I also like to mention, like I just forgot to mention here, that all the codes we are using are in Java. So this is one of the another limitation for us, that we are mostly considering Java projects.
Thank you very much, because it was my very technical question. How you can manage different languages, even in spite of some similarities? Let me say C++, or Java, between C++ and Java, nevertheless, they are very much different. Thank you. More questions, please.
But they just use metrics, so they can calculate the same metrics using different languages, so it is not a problem, I think. And my next question is, how about anti-patterns?
Yes, this is a good question, actually. I mean, it is a good question, because in open source project, we can see these anti-patterns a lot, like especially when normal developers are writing, they do not focus on this. So it's not included. We are not talking about anti-pattern, but it's there in our head that somehow we should detect anti-patterns, and again we should have some correlation with everything else, but maybe in future it's not straightforward for us that how we analyze it.
Because the question was for me, because you have said that you want to find relations between the usage of patterns and the code quality. And for me, it is also unclear. How can you detect such a relation?
Yes, so first thing is that in to go to this level, we need to first identify for each project that which code quality, software quality they are targeting, right? So what is the requirement, software quality requirement? Not all the quality is important to my project, right? So we need to have some kind of data in that respect, where for each project we know that which software quality are priority, and then we kind of do something. So the first step will be to have these quality requirements in hand for all the projects in our data set. And from there onwards, we see that what's happening with this particular code quality. So we are still not clear about it.
Okay. And what about new patterns? Because you mentioned this book, and it was written about 20 years ago. And since the time, there are a lot of new patterns have appeared. And what about new patterns?
Yes, but still the most used are from this book, right? How we say, the popular patterns which are being used in frameworks or generally developers use are most still from these Gang of Four books. So we decided we will just focus on now, but you're right that yes, a lot of patterns have evolved and um, there are a lot of variation and so on. So yes, in future we will consider it. But for now, we will just try to go broader and try to say on a broader level for creational, structural, and behavioral. There also, we are not going further deep and saying which behavioral or which creational, just to be simple for this paper. So we need to actually submit a paper on this particular topic soon. So all our research is right now focused towards writing this paper, and all these points which we are coming up with is kind of, it's there, but we are not working on that. And in our paper we are going to have a limitation, or let's say future work, where we will try to work, and we will need to more people to come, because right now there are only 2 people who are working on it. So it's a good opportunity for me also to maybe get input from you and maybe ask or request you to come if you're interested.
Yeah, and I know that in Innopolis there will be a conference on code quality organized by Egor Bugayenko, and are you going to send your paper to this conference or another conference?
No, we are targeting some Q2 journal. Actually, there was I'm sorry, just for a second, my charger. Yeah, not really. We are not sending it in this particular conference. Earlier, we were supposed to send it somewhere, but our results were not ready, so we cannot. But we try to send it to some Q2 journal.
Okay, but
Yeah.
for my side, that the research contributions are not well done, and for me, just calculating some metrics and training some networks are not a good resulting point. And but maybe you will be lucky.
Yeah, I mean, like, so our idea is to send to some good journal and kind of get rejected and get some review.
Okay.
And this will also give us this time, because we started writing this like 1 month back, so it's like 1.5 months. So we send it to something there and wait for what they say about it. And during this period, we are also working on our results and further expansion.
Okay.
Thank you very much. Just a short question from my side to Sergey. What conference do you mean? I just in parallel, I try to figure out what is the conference organized by Egor Bugayenko.
International conference on
could you please just share in the chat? I see. ICCQ.
International conference on code quality. I think it could be iccq.ru. And yes, because with my student last year we have sent a paper to this conference, and the peer reviewing was good, and this was a good organized committee, but they rejected almost all papers. So yes.
So Swati, please be prepared.
Yes, in our head we are prepared that it will be rejected, but yes, it's yeah, it's our practice for Q2 journal.
Any more questions, please?
I can just comment because I know that nowadays in software engineering, it is a big branch of analyzing real source code of real repositories, and there is such a trend in software engineering to analyze the behavior of real developers, and so you are in a trend, but yes, you should prepare, I think, more deeper code analysis and check relations between classes. Like, okay, but maybe yes, they accept.
Actually, we want to research on this particular area, but we didn't know where to start from. Like, I did some course on design patterns, so I had some understanding, and my friend is more friend and the author is more interested in machine learning models, so we did some literature review and we understand that this could be a good area, and it's good for us that we are getting such inputs, and I would like to keep presenting it later, so that we have good understanding and we are not lost. So from the point of view of submitting this paper, it's a kind of warm up for us, which kind of also motivate us to work towards it and see we are doing, is it even worth, or is it contributing or not?
Yeah. It is a good idea to send something and take good feedback. Maybe they publish, maybe they not, but nevertheless you will have good feedback.
And also, like, presenting here, like here right now in Innopolis, and also I'm doing a course about writing a paper, and there also I'm using this paper to kind of get all this kind of feedback. For us, it's more motivation when we get some criticism. It says that, okay, we need to work more, and we work then.
Yeah, Gerald Bryden, I don't know who is it, but yes, he said that he sent a paper to ICCQ conference and they were very strict. Yeah.
Yes, I submitted a paper last year and they were so strict. I think, yeah.
And what scores did you get?
Score? You mean score?
Review scores.
Rejects.
It is private. It is private information. It is private information.
No, but I
even
think
working seminar and friendly atmosphere. Well, it is nevertheless a right of everyone to maintain some privacy, protect some privacy.
Yeah, but of
yeah.
course, I was interested in this conference, and I just checked their papers, and they published it in IEEE, and I see no citations of these papers. So they selected good papers, but nobody cited them. In a year, yes.
But maybe it is relatively new conference, no?
Yes.
Yes, so it will be second. It will be second edition. I already checked the web page. It will be second edition. The first edition was in Moscow, organized by Moscow Physics and Technical Institute.
I will check this. Probably, maybe we can send it there and get rejected, and then don't send it to Q2.
The deadline will be in December of this year, so you could try.
Okay. Yeah.
So, more questions, please.
Yes, I am very interested in teaching design patterns, because you said that your co-author is a teacher of design patterns. And, yes,
no, he is a machine learning expert, and I am the teacher. I was TA for one of the I was a TA for a design pattern course, so I got some interest from there.
Okay, and you said that your students wrote some code using design patterns, and you include this code into your data set.
Training set, basically training set.
Yes. And could you please explain the tasks and how the course was organized?
Okay, so the course was basically teaching students all the design patterns, creational, structural, and behavioral. And they, of course, have assignment. So they were supposed to choose a project which they want to do, and then while doing this project, they were supposed to use several design pattern in these projects. So and then instructor kind of grade them whether they used it correctly or not, whether it was necessary to use or not, and so on different criteria. So all the codes, all the projects we used have some kind of design pattern in it. We know it because we took it from the course, which enforced these students to use some design patterns.
And
if you're interested, we can also provide you with the data set and you can have a look.
Okay. And just a question, how many patterns each student should use in his work?
Okay, so first of all, it was very much dependent on the project they are choosing, because choice of project was on a student. It was not, we didn't ask them to use a project. I mean, a certain project, because we know that some projects we can use some kind of design pattern. Then student choose some project which are interesting to them, but then they cannot use all the patterns, or it's less chance that there will be some patterns required. So they were asked to use, I guess, 3 to 4 major patterns, but I'm not sure about it. I will clarify, because this course is different than which course I taught. And in my course also students were supposed to use. And in my course, we didn't include the data set from there because of several reasons. But 3 to 4 major patterns, that is what they were asked. Yes. And if we see from our glimpse of result, it's mostly they use the creational design patterns in extensively.
Like a fabrical method or something like this. Okay.
So, if no more questions, let's thank Swati and Sergey for contributing by questioning and comments. Thank you both, and speaker first. And let me make some advertisement about our plans in December. First, in December we will have I expect 4 seminars every week. First of all, of course, it is not obligatory to attend, but nevertheless, you are very warmly welcome. First, next week, we will have a talk by Sergey, by Alexander Koktenkov. It is already advertised on the web page of our seminar. Next week, we will have talk by Vladislav Polyotin from Novosibirsk. He will give a talk about scheduling, automatic scheduling of parallel processes. Then we will have talk, I hope, from Vitaly Romanov, also in this. I believe that today Swati mentioned Vitaly research on vectorization of program code, right? Do you mean his Vitaly research? I believe.
Probably not.
Not
really, but
no, but maybe now.
So next we expect Vitaly talk, and finally, a year ago we started a tradition to have last meeting, last annual meeting devoted to problems. I don't mean great problems and challenges, but challenges and great problems are welcome. Basically, it will be session with short presentation about problem, question, research questions that was most interesting for presenter during the last or maybe couple of years. So now December 30th, we will have a seminar meeting devoted to problems. Don't expect that it will be challenge, but present what was interesting for you during this year and what is still a research topic for you for next year and maybe for a couple of years. So thank you very much. Thank you, Swati, once again. It will be very nice of you to send me slides, and I will post slides and recording on the website of our seminar early next week. So thank you all. Bye.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.